So now let's walk through some ideas that we could use to develop a predictor. The first, and perhaps simplest and laziest idea, is just to simply take the mean, or the arithmetic average, of all of the elements of the training data, and then we can predict all the missing entries by that same value. And in order to do that, we just add up all the values in the training data, and we divide by the total number. So we have to add up 5, 4, 2, 4, 4, 3, 2, 2, and so on. And remember, we're not going to use any of the elements that are in blue and bolded, because those are elements of the test data. And so this, we'd say that the mean is equal to 5 plus 4 plus 2 plus 4 plus 4, and so on. And I'll just underline the rest of those entries here. 4, 5, 3, 5, 1, 4, 4, 4, 4, 3, 2, 5. And there's 20 of those total, so we divide by 20 because we're taking the average. And it turns out that that comes out to be 3.5. So the mean of the elements in the training set is 3.5. And so the result is shown on the right-hand side over here, that once we take the mean of all the elements in the training set, we're basically having for each entry the same value, and we're just having 3.5 for all the different entries. And so now to evaluate that, we can go ahead and look at the RMSE. And we're going to walk through the computation for the RMSE step by step. And so we can do an RMSE on the training data, and we can also do an RMSE on the test data. And we'll focus here on doing the RMSE on the test data, and we'll just write out the value that we get also on the training data. And so the first thing you do when you take the RMSE is we move backwards in the acronym here. And so the first thing we want to do is we want to square the difference. And so what we mean by that is we want to square the error in the prediction, which is squaring the difference between the actual values and the values that we've predicted. So for instance, we predicted a 3.5 here, the actual value is a 4, so that difference would be 0.5. And similarly for user D in movie 2, we predicted a value of 3.5, but the actual value is 2. And so on. We do that for each of these 5 elements. And so, you could just write out, for instance, for user C movie 1, that when we square the difference, it's 4 minus 3.5 squared. And we do that for each of the elements. So then you have the next one, D2, would be 2 minus 3.5 squared. Then the next thing we do is we take the mean of all of those squared differences. So since there's 5 elements, we're just basically adding up all the differences. So we're taking 4 minus 3.5 squared plus 2 minus 3.5 squared plus 5 minus 3.5 squared plus, and so on. We do 3 minus 3.5 squared, and we do 4 minus 3.5 squared. And we're going to divide that by the total number, which is in this case 5. And then at the end, we just take the square root of that whole value, because since we squared everything in the first place, we want to take the square root to bring that back down to normalize it. And so what we end up getting for the entire thing, once we take the square root of the whole set of data, is 1.0247 as the RMSE, and that's for test data. And additionally, we could, as we said, we could do the same thing on the training data, and we get 1.1619, and that's for the training data.